You want to know what makes me lose sleep in 2026? It is not engine failures. It is not transmissions grenading on the highway. It is a window, a piece of glass that refuses to stay up. You are sitting in a parking lot. Maybe it is raining. Maybe you are in a neighborhood you do not want your car sitting wide open in, and you pull that switch up to close your driver window. The glass goes all the way to the top, kisses the rubber weather stripping, and then like some kind of haunted elevator, it just drops back down halfway on its own. You pull the switch again, it goes up, it touches the top, it drops again, every single time. The glass is mocking you. Your car is now a convertible you never asked for, and the sky is about to open up, or some opportunist is eyeballing your laptop bag on the passenger seat, so you do what any reasonable person does in a state of panic. You drive to a shop. You explain the problem. And the service advisor, this guy who has been trained not to fix your car but to maximize the revenue extraction from your emotional distress, he puts on this grave face like he is about to deliver a terminal diagnosis. He disappears into the back for 20 minutes, comes out holding a clipboard, and says the words that are designed to make your stomach drop. Your window regulator cables are stretched. The motor gears are stripped. The door control module has a burned circuit. We need to tear the entire door apart, replace the regulator assembly, and reprogram the module. $600. Parts and labor, and you are standing there, rain starting to fall through your open window, thinking you have no choice. $600 for a window. In 2026, with groceries costing what they cost, with insurance premiums through the roof, with every single monthly bill competing for the same shrinking paycheck, $600 to close a window. I am here to tell you that in the overwhelming majority of cases, that diagnosis is a complete and total lie. Your window motor is fine. Your regulator cables are fine. Your door control module is fine. The only thing broken in your car is 10 seconds worth of software memory. And I am going to show you how to fix it right now without a single tool, without spending a single cent, without removing a single door panel clip. The dealerships making billions off your frustration want you to think a bouncing window means shattered internal gears and melted circuit boards. It almost never does. What it actually means is basic Hall effect sensor calibration and anti-pinch algorithm confusion. But as always, I am sharing this old-school software bypass for educational and observational purposes, because understanding your own vehicle's engineering is your right as the person who paid for it. Let me walk you through exactly why your window is doing this, because once you understand the engineering, the Stealerships diagnostic scam falls apart like wet cardboard. Your power window moves on a device called a window regulator. There are two main types. The older style is a scissor regulator, which looks like a pantograph, an X-shaped metal linkage that expands and contracts to push the glass up and down inside the door. The newer and more common style, which is what you will find in almost every Japanese and Korean vehicle built after 2005, is a cable regulator. This is a steel cable looped around a set of pulleys inside the door, attached to a bracket that holds the bottom edge of the glass. When the electric motor spins in one direction, the cable pulls the glass up. When it spins the other direction, the cable lowers the glass down. These cable regulators are remarkably tough. The cables are braided steel. The pulleys are hardened. The bracket is stamped metal bolted directly to the glass. These components do not just randomly fail at 60,000 miles. They are designed by engineers, Japanese engineers specifically, who understood that a window mechanism needs to survive hundreds of thousands of cycles over the life of a vehicle. The motors themselves are small but powerful DC units with a worm gear reduction inside. That worm gear is the key. It provides massive mechanical advantage, which is how a tiny motor can push a heavy piece of tempered glass up against the friction of rubber weather stripping and felt channel liners. And here is the critical part. That worm gear is also self-locking. When the motor stops spinning, the worm gear physically prevents the glass from sliding back down under its own weight. So when a Stealership tells you your window is falling down because the gears are stripped, ask yourself this. If the gears were truly stripped, the glass would not go up at all. The motor would just spin freely, and you would hear a whining noise with zero movement. But your glass does go up. It goes all the way to the top. It completes the full travel. The motor has plenty of power. The cables are pulling correctly. The regulator tracks are aligned. Everything mechanical is working perfectly. The glass then reverses. That reversal is not mechanical. That is software. That is a computer making a decision. And the Stealership is charging you $600 to replace hardware that a computer decided to override. That is not a repair. That is a con. If this kind of engineering truth is the reason you watch this channel, if you are tired of mechanics trying to sell you a brand new window motor and a complete door teardown when your car just has a confused computer, hit the like button right now. The algorithm buries channels like this one because we do not sell you parts. We save you money, and saving you money is not profitable for the people who pay for ads. Every like pushes this video past the suppression filter so another driver does not get fleeced for $600 over a software glitch. And tell me in the comments right now, has your window ever bounced back down on its own, and what did a dealership or a shop try to charge you for it? I read every single comment, and the stories you share help other viewers recognize the scam before they hand over their credit card. Now let me show you how deep the Stealership rabbit hole goes on this particular job. When a service advisor quotes you $600 for a window regulator replacement, here is what that number actually contains. The regulator assembly itself, which is the cable, the pulleys, the bracket, and the motor as one unit, costs the dealership somewhere between $40 and $90, depending on the brand and whether they source OEM or aftermarket. Let us be generous and say they are using a genuine OEM part from the manufacturer's parts warehouse. Maybe that part costs them $120 at dealer cost. They mark it up to $200, $250 on your invoice. Then comes the labor. The flat rate guide says a window regulator replacement is somewhere between 1.5 to 3 hours depending on the vehicle. At a dealership labor rate of $150 to $200 per hour in 2026, you are looking at $300 to $450 in labor. So the math works out. $250 for the part, $350 for the labor, $600. But here is where the crime happens. The labor itself is real work. I am not disputing that. Removing a door panel is tedious. You have to carefully pry out the plastic clips without snapping them, because replacement clips cost $8 to $12 for a bag, and they never fit as tightly as the originals. You have to disconnect the wiring harness for the window switches, the mirror controls, and sometimes the door lock actuator. You have to peel back the plastic vapor barrier without tearing it, because that barrier is what keeps rainwater that enters the outer door skin from soaking your interior. You have to unbolt the glass from the regulator bracket, support the glass so it does not fall into the door cavity and shatter, remove the old regulator, install the new one, reattach the glass, reseal the vapor barrier, reconnect the harnesses, snap the panel back on, and then you still have to perform the exact software calibration I am about to teach you for free, because the new regulator also needs the anti-pinch system to learn its travel limits. 3 hours of real skilled work. Except your car does not need any of it. Your regulator is not broken. Your motor is not burned. Your cables are not stretched. The only thing wrong is that your door control module lost its calibration data, and a technician who understood the engineering would diagnose that in 30 seconds, perform a relearn in 10 seconds, hand you your keys, and maybe charge you a $20 diagnostic fee. But $20 does not pay for the service advisor's commission. $20 does not cover the dealership's overhead on that heated customer lounge with the espresso machine and the mounted television playing daytime talk shows. $600 does. So they sell you hardware you do not need and labor you do not require to fix a problem that is entirely in software. In 2026, this is one of the single most profitable quick-hit scams in the dealership service bay, and it happens thousands of times a day across every single brand. So let me explain the actual science of what is happening inside your door when that window bounces back. This is where it gets fascinating because the engineering is genuinely brilliant. It was just never meant to be weaponized against your wallet. Starting in the early 2000s, safety regulations in Europe, North America, and Japan began requiring something called anti-pinch protection on automatic power windows. The concern was real. An auto-up window, meaning a window you can tap the switch once and it goes all the way up on its own without holding the button, generates enough force to seriously injure a child's hand or arm if it closes on them. The forces involved are significant. A window motor driving through that worm gear reduction can generate 40 to 80 newtons of clamping force easily. That is enough to break small bones. So, regulators mandated that the window system must be able to detect an obstruction and immediately reverse. The question was, how do you detect an obstruction? The answer is the Hall effect sensor. Inside the window motor, or mounted directly on the motor shaft, there is a tiny sensor that uses the Hall effect, which is the production of a voltage difference across an electrical conductor when a magnetic field is applied perpendicular to the current flow. In practical terms, a small magnet is attached to the motor shaft, and as the shaft spins, the Hall effect sensor generates a series of electrical pulses. Each pulse corresponds to a specific increment of rotation. The door control module counts these pulses. By counting pulses, the module knows exactly how many rotations the motor has made, and since each rotation translates to a specific amount of cable travel, the module knows exactly where the glass is positioned at any given moment, from fully down to fully up and every millimeter in between. But here is the critical detail. The module does not just track position. It also tracks the rate of change in motor current draw. As the window glass travels upward through the felt channels and weather stripping, the motor draws a relatively consistent amount of current. But when the glass encounters an obstacle, the motor has to work harder. The current draw spikes. The module detects this spike, compares it against a threshold, and if the spike exceeds the threshold, the module assumes an obstruction is present and immediately reverses the motor to drop the glass back down. This is the anti-pinch algorithm, and it works beautifully when it is properly calibrated. The problem is calibration. The module needs to know two absolute reference points. It needs to know the precise pulse count at the very bottom of the glass travel and the precise pulse count at the very top. With those 2 points memorized, it can map the entire travel range, and it knows that when the pulse count reaches the maximum, the glass has reached the top of the door frame, and the current spike it detects at that point is just the glass pressing into the rubber weather stripping, not a child's arm. It expects that spike at that position, and it allows the window to stay closed. But if the module loses power, if your battery dies overnight, if you disconnect the battery to replace it, if your alternator hiccups and the voltage drops below the module's memory retention threshold, if you replace a blown fuse on the door circuit, the module's volatile memory resets. Those stored reference points vanish. The module no longer knows where the top of the door frame is. So the next time you auto up the window, the glass travels to the top, hits the weather stripping, the current spikes, and the module, having no stored reference for that position, interprets the spike as an obstruction. It thinks the rubber seal is a solid object. It thinks your weather stripping is a child's arm, and it does exactly what it was designed to do. It reverses the window to protect what it believes is a human being trapped in the glass. Your window is not broken. Your window is being a hero. It is saving an imaginary child from an imaginary danger because its memory got wiped and nobody told it where the door frame ends. That is all that is happening. Software amnesia. And a Stealership will charge you $600 to replace the hardware that was doing its job correctly the entire time. Now, here is the relearn procedure, and please listen carefully because the order and the timing matter. Before you begin, make sure the ignition is on. The engine does not need to be running, but the key needs to be in the on position, or if you have push-button start, press the start button without your foot on the brake so the electronics power up. This is important because the door control module needs power to write new reference data to memory. Step 1. Press the window switch down, the full press, not the auto down tap. Hold it down manually and let the glass travel all the way to the absolute bottom of its track. When the glass reaches the bottom and the motor stops, keep holding that switch down for 5 full seconds. Count them out. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. Those 5 seconds are not arbitrary. During that hold time, the Hall effect sensor is sending a steady stream of zero movement pulses to the module, and the module interprets this sustained zero movement signal at the end of downward travel as the command to write the current pulse count as the new lower reference point. You are telling the computer this is the floor. Remember this. Step 2. Now, pull the window switch up, again a full manual pull, not the auto up tap, and hold it as the glass travels all the way to the top. Let it go all the way up until it seats firmly against the weather stripping and the motor stalls. Then keep holding the switch pulled up for another 5 full seconds. Same count. 1 Mississippi through 5. The module is now writing the upper reference point. It is memorizing the exact pulse count where the glass meets the door frame, and it is tagging that position as the expected endpoint, not an obstruction. Step 3. Release the switch. Now test the auto up function. Tap the switch up briefly, the way you would normally use one-touch auto up. The glass should travel smoothly to the top, seat against the weather stripping, and stay there. No reversal, no bouncing, no ghost window. The anti-pinch algorithm now has its full calibration map restored, and it knows the difference between the door frame and a foreign object. A critical safety note here. During the relearn procedure, keep your hands, your fingers, your hair, loose sleeves, anything completely clear of the window track. The glass is going to travel through its full range, and during the calibration sequence, the anti-pinch protection may not be active because you are literally resetting the system that provides that protection. Treat the window opening like a guillotine during this process. Nothing goes near it until the relearn is complete and verified. Also, do not put anything on the door sill or in the window path. No phone, no coffee cup, no arm resting on the door. Clear the area completely. Now I have to be honest with you about the limits of this fix because my credibility with you is more important than views. If you perform this relearn procedure and the window still bounces back, or if when you roll the window up you hear a grinding, crunching, or snapping sound from inside the door, That is a different situation entirely. That sound means the physical cable has frayed or jumped off a pulley, or in rare cases, the regulator bracket has cracked. No amount of software resetting will fix torn steel or a broken bracket. At that point, yes, you do need the regulator replaced. But you will know the difference because the sound is unmistakable. A software calibration issue is silent, the window moves smoothly and powerfully in both directions, it just refuses to stay at the top. A mechanical failure is loud, ugly, and usually involves the glass sitting crooked in the track or not moving at all. Subscribe and hit the bell right now before the automotive parts lobby figures out that channels like this are costing them millions in unnecessary regulator sales and decides to flag this as dangerous content. Make sure you check the featured section below this video because my secondary channel goes even deeper into the engineering they do not want you to understand. We are hitting them from both sides. Share this video with anyone you know who drives a car built after 2005 because every single one of them has this anti-pinch system and every single one of them is a potential target for this exact diagnostic scam. Your window is not broken, your car is not falling apart, a computer forgot where the ceiling is, and for 10 seconds of your time and $0, you can remind it. I will see you in the next one.